Welcome to another video from Lockdown Electronics with me, Bill, and this time we've got another review, and it's the ZOTEC or ZOYI ZT 702S oscilloscope and multimeter. Now this is a very new item. It's only just becoming available, so I'm pleased to have got an early sample of this to try out. ZOYI sent me this, no obligation to do a review on, which is what you're now about to watch, so let's get into it and see what this thing's like. Okay, let's see what we get in the box. We've obviously got the instrument, pop it there for a moment, USB-C lead. This does have an internal rechargeable battery which is recharged through USB-C. Set of fairly standard probes, a thermocouple with a handle on actually, so that's a bit more of a usable thermocouple than you sometimes get. A scope probe with its various coloured rings on there, and a user manual, and the whole thing comes in this padded case. So meter feels nice and solid, and on the rear you've got a little support like that. It's not particularly strong, but it does the job, and since I guess you'd be wanting to look after this with your instrument, then you'd be wanting to be nice to it anyway. Okay, let's get it connected up and see what it'll do. Okay, so I've taken off the protective screen, and we'll connect things up in a moment. Let's just have a look at the interface for a start. So a long press on the on button, and the machine boots straight into scope mode. Yellow time-based line running across there, various bits of information around the screen, and then pressing the mode button will swap between a scope and multimeter. Single press to do that, and then you've got various settings that run across here with the 4 function keys. So we've got voltage here, and hops between DC and AC by pressing that, and then this one we get resistance, we get continuity, we get diode, and we get capacitance. On here we've got current. There's a little warning first of all to remind you to make sure you reconnect the probes, and we've got the AC and the DC current, and also across here we've got current, but this is in the microamp range. We've also got shows you the frequency there. So those are the settings, and then pressing mode hops us straight back to scope again. So we'll have a quick look at what the meter will do, and then we'll have a look at how the scope does. Okay, I'm going to start here with capacitance for no other reason than I can do. I was intrigued to see how it'd do. So I've got a range of capacitors here, and this is 56 picofarads. So let's see what she makes of that. It's quite a small one, and very quickly tells me it's about 59 picofarads, so that's pretty good for a very small value capacitor. This one's labelled as 680 picofarads. Comes up here at about 767. On my LCR meter this comes up at 770, so I think the LCR meter agrees with the ZOYI here, gets a nice reading for that there. So onto a couple of electrolytics. I've got a 220 microfarad here. It's going to take a moment to charge that, I guess. So there we go, 244, labelled as 220, so I think that's pretty good, showing it as microfarads. And then order of magnitude higher here, I've got a 2200 at 10 volts. So let's see what she makes of that. And it's gone to the millifarad range already, so we're just waiting for a result. 2248. Yep, pretty good. So I quite like the way it responds on capacitance, and nice nice snappy display that gives you the information you need, so I like it. Yeah, I'm very impressed it's managed 56 puff without too much trouble. Yeah, 60 nanofarads, that's pretty damn close for a very small value capacitor, so yeah, I like it. Right, I'll get set up for some of the other ranges now. Okay, let's have a look at resistance. So I've got a very small one, a very large one, and somewhere in the middle. This is marked up as 220k. The meter makes it 267. The LCR meter on 4-wire mode also makes this about 267, so that's the meter here is giving a correct reading for that resistor at around about 267k. So let's really make it suffer. Here's a 4.7 ohm resistor, so very tiny indeed, and it's done rather well there and getting it to 4.7. I feel that's pretty good for a very small value resistor. So let's whiz along to this one here. This is marked as 8.3 mega ohms, but in reality on the LCR meter it's a little less than that, and the meter, this ZOYI meter, agrees with the LCR meter. It comes out at about 8.1 meg. So yeah, from very high resistance right down to 4.7, seems to be doing that rather nicely. I guess you'd expect that of digital multimeters, but these kind of things are the handy ranges for the hobbyist, I feel. So far I'm liking these meter modes. Right, let's have a look at voltage and current. Okay, let's look at voltage then, and we'll do a bit more resistance, but we'll also then look at current. So I've got the meter currently in voltage mode here. Need to make sure I get the probe into the right connection like so, and I've got a LED 330 ohm resistor here. So first thing we'll just check is roughly what supply voltage we've got. I'm anticipating it being around just over perhaps 5, yeah. So I've got a 5.1 volt supply. That agrees with what my bench power supply is putting out. And so the next thing I want to check is the voltage across this resistor here. So I'll just do that, and we get in about, let's call it 2.1 volts. Okay, 2.1 volts. Let's now take the LED out of circuit there, and let's just now measure the resistance. So 327 ohms, let's call that, gives us just over 6 milliamps, according to the calculation. So let's now set the meter up. So we'll take positive lead and put it in 10 amps. I'm going to select amps there. You get a brief warning about that. I'm now going to include the amps in the circuit, make the LED light up like so, and surprise surprise, we're getting pretty much the same answer that we got from calculation. So the meter agrees with itself. So I'm just reading the average. I don't know how easy that is to see. It's the bottom right hand side just above the function key icons. It's saying average is about 6.3 milliamps, 6.2 it's saying now. So that's agreeing with the maths. Now if you want to go on to milliamp mode, move the connection to there, select milliamps there, that now lights up red, and let's connect up again. And what we're now getting is a reading of just over 6,000 microamps. It's interesting it does it that way, but if you look at the average there, we're getting an average there of about, need to push the connections on a little bit harder, I think. There we go. Get an average of about just under 6 milliamps. So again, that's the meter pretty much agreeing with itself. and doing it rather nicely. Once you've got your head around the fact that 5,600 microamps is 5.6 milliamps, it all makes complete sense. It's a little tad confusing until you do that. So there we go. Meter agrees with itself on voltage, resistance and current all measured together there. So there are a couple of other functions. There's frequency and things like that, but I think what we'll do now is we'll move on to the bit that a lot of people will be interested in, I guess, and that's the oscilloscope function. So I'll get set up for that and then see how we go. Okay, so I've got the supplied probe connected up at the top. It comes with a little trimming tool here to allow you to correct the probe, and the connections for that are on the side here, ground and output pin are there. So I've got the probe attached there, and the adjustment is here on the actual socket connection that goes into the scope itself. But as you can see from the shape of the waveform, if I open that out a bit more, it's absolutely fine. It doesn't actually need adjusting, but that probe adjuster does drop into that socket just there to allow you to trim the probe if you need to make sure you've got a flat top. And so now we can see the scope functions rather nicely. So it's telling me 1000 hertz, 1 kilohertz, and currently we've got 500 millivolts per division here, so 3.4 peak and 1.5 voltage max. So it's recording those things okay. If I change from AC to DC coupling there, you can see straight away the wave shoots up, but taking that back to AC, the trigger fairly quickly locks on again. So if you want to move things about on the display, you go to press the function button for move, and that allows you to move the display, and you can hopefully see the little marker moving just there. If I just move that back onto center there, and then I can adjust up and down. You can obviously see that yellow marker is moving up and down as I do that, and then popping back to volume and time gives me adjustment of the X with the, I guess it's the Y amplifier, if you like, as it used to be called. Allows me to step that up there, so I go down to 2 volts per division there, and then the left and right button allow me to change the time base, so can hopefully include lots of waveforms for you there on the display. So that should hopefully be making some sense, and it's certainly showing that nicely. So what I'm going to do now is I'm going to attach it to my signal generator, and we'll have a look what its response is like with higher frequencies. Okay, here we've got the scope running. Then I've got it attached to my signal generator through a 50 ohm termination, so I'll switch the signal generator output on, and we've clearly got a waveform there. Now we're in volume time mode on function 1 here, so I can use the cursor keys to adjust the amplifier, Y amplifier, and also the time base. But I want to show you the auto function, so I'll just tap auto and we get the auto setting display, and in a moment or two it'll tap through and produce a display. So you can see there, frequency 1000 kilohertz, voltage it's 1.03. Let's just make that a little bigger so we can see the waveform there, and I've deliberately set the voltage at 1 volt so we can do a bit of bandwidth checking. So I'm currently at 1 megahertz, so I'm now going to go up to 5 megahertz. That's 5 megahertz there. So again, we can extend the time base, and still same 0.94, so we're well within the minus 3 dB. And I'll go up now to 10 megahertz there, which is the stated bandwidth, and it's starting to be a bit of a challenging display. I think, to be fair to the scope, my Hameg analog scope is stated as 10 megahertz and displays a similar kind of thing, so it's not doing too bad really. If we come back down to 9 megahertz, it starts to stabilize quite quickly, and it's pretty reasonable at 8 megahertz, and at no point was it below 0.88 volts, so it's well within its 3 dB down point. So I'll go back to 1 megahertz there, and we'll just get the wave displaying like so. So I'm going to show you one or two of the other things that it's capable of. Incidentally, if you tap the menu button, you get all the settings come up, and they change depending which function key you've pressed, so it's just worth bearing that in mind if you're trying to find a setting. So if we go on to function 4 and AC, it come up there and it gives you things to do with trigger mode, etc., and pressing menu returns you back to that one. So now what I'm going to do is I'm going to give it a modulated signal. So defaulting here, I've got 50% modulation at 500 hertz, and you can see the display is jumping about as it should, because that's correct. So what I'm now going to do is adjust the time base until we can actually see the modulation envelope. Now triggering is obviously struggling with that, but if I stop the display, you can see, yep, we've got rather nice 50% AM modulation. I think it's showing that rather nicely actually. So that'll carry on running again, and if we want to up the modulation to say 100%, I'm just going to turn the bandwidth down a bit so you can, oh no, I'll leave it there actually. So if we stop that, you can see we've got 100% modulation there. I'll just drop it down so you can hopefully see that. Obviously being AM, when you turn up the modulation, the peaks get higher. So it is doing what it's supposed to there, and displaying a modulated signal quite nicely, so you could certainly use that for looking at a transmitter output, and the display's nice and clear. Now what I'm going to do is give a long press on there, and I don't know whether you noticed that, but it essentially there it saved the screen. So we'll just have a look at that screen, which you can download by connecting to the USB port, which is there. So there's an example of the screen grab, which is hopefully useful. So I'll turn off modulation, just do an auto, and we should be back at 1 megahertz eventually, and there we are. So yeah, that's quite nice functions for a scope, and considering the price of this thing, quite remarkable. I'll tell you what is quite interesting as well, and that is if I go up to 20 megahertz like so, obviously the display is confused, but it still is reporting the correct frequency. Now this signal generator will do up to 30 megahertz, so if I go up to 25, again, display is very confused. It's well beyond its bandwidth, but it is correctly identifying the frequency. And if I go right to the very top of this, what this signal generator will do, well, there we are at 30 megahertz, and yep, it's showing up the 30 megahertz rather well. If we drop down to 29.5, yep. So frequency counters certainly pretty good, although obviously wouldn't expect the display to be showing you anything sensible. It's well beyond its 3 times beyond its bandwidth. There we are, back to 1 megahertz again. So I just think that's quite nice the way it displays that. So there you go, that's functions of the scope. Okay, well there you have the ZOYI, or not quite sure how it said, ZOYI ZT702S oscilloscope and multimeter. My first look. I'm actually rather impressed with that. Now I do appreciate there are one or two of you out there who will often comment that these budget Chinese instruments, I'm often get told they aren't any good. Well, I think you've just got to balance that with what these things actually sell for, and currently this is up for sale on a couple of websites that I'm going to link down below for just over £60, and in one case includes free postage. That's an awful lot of instrument for that kind of money. No, it probably isn't something you'd use professionally, but for somebody in an electronics lab, I think that's amazing. I'd have been delighted with that when I was first getting into electronics, and it seems to do the job rather nicely. Now, something I've not shown you on here is when you do get into these menus, there are actually lots more options. So maybe I'll do another video on this at some point where we look at some of the if you like, the extended menus, and also I'm going to use this for a bit and sort of get comfortable with it and see how it works out for me. So if that's something you'd like to see, just put a comment below. Certainly be interested in that. But yeah, incredible for the money, I think. Really quite remarkable. So yeah, nice. Hope you've found that useful. If you're not into reviews, you didn't need to watch it. Otherwise, thanks very much for watching, and look forward to seeing you on the next video.